So in this lesson, I will try to explain what is difference between position, distance, and displacement. So let's start from position. Suppose we have a person or a man A who wants to meet man B. So this is straightforward. I can say what is distance between them. Let it be equal to 800 meters. So this is distance. If you provide this information, that is 800 meters, to this man A, then he won't be able to meet his friend B. Why? Because this man A can move 800 meters in any direction, right? Or in fact, you can say this man can move in a circle whose radius is 800 meters in any direction. So this 800 meter, which is distance between A and B, is insufficient information. So what we will do, we will ask this man, again, this is man A and this is B. We will ask this man A to move in this direction, that is 800 meter, and let this direction be equal to x. So now we will say 800 meter in x direction. So now this quantity has direction as well as it has magnitude. So this quantity is nothing but position. So this is position of particle B. This information, which has magnitude as well as direction, will enable man A to reach or to meet his friend B. So we can define it as x is equal to 800 meter, or rather we can say plus 800 meters. So this plus is direction and 800 meter is magnitude, right? The same man, this is A, now wants to meet another friend C, but now distance between them is say 400 meter. So now we have to give information to A such that he is able to meet his friend C. So now I will say x is equal to minus 400 meters. So minus is nothing but direction and 400 meter magnitude, right? So now again, this is vector quantity and this is position of C. This is position of C. When you give this information to A, then A will move towards minus direction. How much distance? 400 meters to meet his friend C. So now I am defining position. So let this be origin. Let this be origin. So here I am saying its x coordinate is 0, y coordinate is 0, and let this be point A, and let it be say 10 centimeter away. So what is position of A? X A, position of A, this will be equal to 10 centimeter. This is say point B. Let this be 8 centimeter. So what is position of B? It is minus 8 centimeter. So now I hope position is clear. Position is vector quantity which have magnitude as well as it has direction. We have seen that position is vector quantity and it is nothing but location of that particle. Next concept that we have to see is that position depends upon frame of reference. What does it mean? Suppose this is our particle A, and we have taken this to be origin or reference point. Let it be equal to 0, comma 0. And if this distance is say 2 meter, then position of particle A will be equal to plus 2 meter. But suppose we have particle A here, we haven't changed its position, right? But instead of taking origin here, I am taking origin here. So let this be the origin. So if this is origin, then if I measure this distance and suppose this distance comes out to be 5 meter, then what will be position of A here? So position of A in this case will be equal to plus 5 meter. If I take origin here, then position of A will be given by XA is equal to plus 2 meter. And if I shift this origin to this point, then position of same A can be written as plus 5 meters. So, of course, position depends upon frame of reference. Now, what is displacement? Displacement is nothing but change in position. So, suppose our particle is initially here. So, what is initial position of our particle? It is 2 meter. And after some time, that particle moves to this point. So, this is final position. Final position, that is xf, will be equal to 5 meter. So this is 5 meter. Now, what is displacement vector? Displacement vector is change in position, that is x final minus x initial. X final is 5 meter minus x initial is 2 meter. So it comes out to be 3 meter. So of course, displacement is vector quantity. This plus represent direction, and this 3m represent magnitude. So this plus indicate that particle has been displaced by 3 meter but towards right. So our particle has been displaced by 3 meters but towards right. Now let's see another example. Suppose initially our particle was here. So what is initial position of our particle? That is plus 5. And what is final position? If our particle reaches this point, so it will be plus 1 meter. Then what is displacement? Displacement we have defined, it is change in position, that is x final minus x initial. X final in this case is 1 meter minus x initial in this case is 5 meter. It comes out to be minus 4 meter. So now here negative is direction and 4 meter is magnitude. So what does this negative sign indicate? That particle has been displaced by 4 meter but towards left. Minus indicates direction, that is towards left. So of course, displacement is vector quantity. It has both magnitude as well as direction. Now let's see difference between distance and displacement. Suppose we have a man and he moves from x is equal to 2 meter to x is equal to 8 meter. And then he comes back to x is equal to 4 meter. So let me draw it. So let this be 2 meter, x is equal to 2 meter, 4 meter, 6 meter, 8 meter. Initially, man was at x is equal to 2 meters. So this is initial point or the starting point. And then he moves to x is equal to 8 meter. So this is x is equal to 8 meter. So he moves in this direction. And how much is the distance between them? So this is 8 minus 2, which should comes out to be 6 meters. And then again he comes back from x is equal to 8 meter to x is equal to 4 meter. So from x is equal to 8 meter, he comes back to x is equal to 4 meter. That means he moved like this. And how much is this distance? It is 8 minus 4, which comes out to be 4 meter. So this is 4 meter. So this is your initial point, and this is your final point. So if somebody asks us what is distance traveled by particle, so distance traveled by particle or distance traveled by this man will be equal to 6 meter plus 4 meter. That comes out to be 10 meters. 6 plus 4, that is 10 meters. So what is distance? Distance is length of actual path traveled by particle, or in this case man. But what is displacement? So in displacement, you say this is initial point and this is final point. So this is initial point and this is final point. So displacement is shortest distance between initial point and final point, which in this case will be equal to 2 meters. So displacement here is 2 meters. So what is displacement? If somebody asks us, it should be shortest distance between initial and final point, right? So when distance and displacement are same, suppose I'm discussing a special case when particle is moving in a straight line and it does not reverses its direction, then I can say distance and displacement will be same. But when I'm saying displacement, I'm talking about magnitude of displacement. So this is for a straight line, and just for information purpose, if a particle travels in curved path, so if a particle travels in curved path and it moves from A to B, so this length of actual path is nothing but distance, and this is the shortest distance between A and B, which will be equal to displacement. So this is displacement and this is distance. Obviously, distance and displacement are different. From objective point of view, if I am having 2 points, point A, point B, what is displacement between them? This is displacement between them. Let it be equal to say 2 meter. But between point A and B, particle can move along different paths. So this is one path. This is say another path. This is say another path. So all these paths, since they are different, distance traveled by particle while following these paths will be different, but displacement will be same because displacement is shortest distance between initial and final point. So